And we're up. Good evening, everybody. Good morning, wherever you are. This is nice. I always wanted to talk on intro music. Can you help me record my voicemail? You've reached Or. He's not around right now. He probably doesn't want to talk to you anyway. You're welcome to leave a message that no one will ever hear. You're welcome to speak into the abyss. Oh, this is beautiful stuff you're playing right now. Wish I had a lighter. So if you've joined us so far, put a message on. Oh, there we go. Give me Beats Caller for free. We barely even started. Please, please, please. Hey, please ask for free products just on one platform, please. So don't attack us on several platforms asking for free shit. Thank you.
You can show some of these comments on screen.
Oh right, yeah, for sure. Let me show. Such a nice selection. Let me show this one. Maybe this one. Oh man. Tell you what, why don't you send us a message on our Discord, either to Or Eyal or even on our Facebook page, and we'll see what we can do for you. All right? We'll gladly try and help you out with that. Is that all right, Gasparino? I mean, you got us started with so many comments. We have to do something for you. Anyway, so we're starting another live stream right now, and we're going to try and do something really exciting for this one. We thought that we'd start letting you in. I mean, Eyal started even before with his coding streams that I really recommend you go and watch. But we thought we'll start and we thought about starting to let you in on our development process and to have you kind of join us and see what it looks like when we're going through the stages of turning an abstract idea into an actual product that is released and you guys can use. And hopefully this would be kind of new and exciting way for us and for you guys to be involved in what we do with Modalics. And this one is actually quite an intense journey, I would say, because it's something that's new for us. We've always aspired to change how people make music. Basically, that's been our sort of goal from day one. And this might be our most ambitious effort to date in that regard. So seeing Beats Caller and Eon as the initial steps, they both exemplify certain ways that we innovated in composition. And this is like our flagship moment, compositional effort project thing, I guess. It's still very early, so we're figuring it out ourselves. So Gasparino is asking for our Discord. How about we post a link in the chat in all the different platforms for our Discord. Eyal, your audio is not coming through if you're speaking to the mic. I think
Oh
you're
yeah,
muted.
yeah. I wasn't saying anything of
Oh,
importance.
cool, cool.
I was nodding and you know.
Yeah. So, besides me talking, we will actually show like the product design process, and we have a very visual way um, to kind of go through the product cycles, and of course we can. I don't know. It's up to Eyal basically, but we can also share some of the actual coding involved, and of course answer questions. This is your opportunity to tackle us with anything related to designing and developing pro audio products, basically, and we'll do our best to answer and sate your curiosity on this topic.
Yeah. So okay. So first of all, yeah. So send a friend request. Okay. So let's kind of cycle to the beginning of what this is, and something that one of these things that I've learned on the stream, on the coding streams that I've been doing the last couple of days. I was writing some audio drivers library that's open source, so I shared it. And one of the interesting things is we're probably going to have to say what this is about multiple times because people are going to join in and out of the stream. Many times people just join halfway through and they're like, "Oh, what is this? What is this stream about? What are you doing?" So, let's maybe give some context about this process that we've been doing. We're making like let's call it a new composition product, right?
Mm-hmm.
And what we're trying to do in this stage is interesting because we're trying to define a lot of elements in the process. Like we're trying to define a lot of things about the product, what it's going to look like, technical things, definitions. We're having some many cycles between us of like, what does this mean to do this? What does it mean to do that? That's something that we've done in all of our products, including BeatScholar, including Eon, including Mindset Drums. Like there's so many of our products have been basically this discussion of us just throwing things like in design or throwing a bit of code and then kind of talking about what it means, what it means to do this. Having feature requests, like we have, we keep asking for features from one to another or from ourselves to ourselves.
Right.
So I thought that it might be interesting to open up this process, and so we're just going to do this discussion with you live. So feel free to jump on the comment section, ask us questions about what it is we're doing. Some of it we might not have answers to because it's all being decided right now. But yeah.
So maybe we can jump in and just describe what the product is about in greater detail. This is kind of a difficult process. We'll need to understand a lot of things ourselves, and you'll see us like live. You'll see this kind of new ideas sinking in. But when we talk about like compositional tools, basically we're talking about taking a sort of seed idea, so it could be a single note or a short phrase, and composing in general is developing music across a timeline. So taking, let's put it into like simple terms, taking a clip of music in whatever resolution and going through a certain process and resulting in a huge, beautiful piece that you want to use and send to instruments and sort of mix and orchestrate and whatever. So the product, just to put a title on it, it deals with that part of the process. It deals with the part where you're seated in front of your computer with your DAW and you want to make music, and we want to be able to facilitate that to our best ability. So how do we go to the next step? The next step would be to identify how we communicate when we make music. So that's basically when before we even write a single line of code or draw a single line in a design software, this is our step one. So once we recognize something we'd like to improve upon or invent, then we have the musical discussion. So just to understand what we'd like to translate using technology, we'd say something like, well, let's say I need to explain, like Eyal needs to explain to Or how to play a certain bass line, or how to make a certain bass line exciting as it corresponds to a chord or just by itself. And that sort of pops out, I have to post this comment, that sort of pops out many questions. And that if we're able to get ourselves excited about the questions that pop out of this discussion, then we definitely feel like we're onto something, and we can start to sort of manipulate that into code and visual cues and stuff like that. So moving back to thinking about the product development process, once we recognize a huge goal like basically composing music, which could be anything from a single one-note pumping bass line for an electronic track to an orchestrated, string quartet piece. You have to cover a lot of ground, but you have to also understand like the lowest resolution possible. What is the very basic elements that make up an evolving piece of music? And that brought us to conceptualize something very interesting, that we need to sort of come up with. Music is a language, so we need to sort of come up with our way to exemplify the language. And this all sounds like, as I'm saying it, I understand the size of the challenge we're facing. So it's basically we have to reinvent the musical language in a sort of way that's user-friendly, and it facilitates your knowledge at any point you're at. So that means if you're just a beginner, we want you to have tools to sort of grow and expand your ideas. And if you're super advanced, then we want to be able to do the same, but offer you tools that are precise and not just like this black box that just generates music for you. So that's a long-ass intro for just giving a sort of background as to what we're facing in this development process.
Yeah. So let's bring it on. So to give you just the technical context, I guess we can start by doing starting to show screens and stuff like that.
Yeah, sure.
I think that what we're doing is,
sorry.
There you go. So what we're doing now is you'll see some iterative process on some idea that we came up that's a little bit like a programming language, but it's not a programming language. There's no text editor here where you type code, but it is an idea that we came up with that's kind of based on elements from programming languages. And we were trying to come up with all these ways where you can kind of manipulate, because a lot of programming languages, or most programming languages, are about like taking some data and mangle that data in some way, manipulate it. And we were trying to do the same with music. Like you have some music and you want to change it. You want to make it longer and more interesting. You want to add variation to that music. So we're building all these little building blocks that would allow you to do stuff like that.
So what we're looking at right now is a sort of classic ideation prototyping sort of process in Figma, which is a very well-known software for doing stuff like that. And basically, a lot of our products will start like this long-ass tree here that I sort of intentionally build it like this. So it starts off here, and I can kind of follow through our thought process. And this is, a lot of the times, it's also backed by text. But it's a very visual way to kind of work. So just to give you like a visual example of what we're talking about, this is one of our first discussions about music being played in forms. So a B part, then two A parts. Like this could be a song form, and this is one of the very basic building blocks that we recognized, is having a musical phrase and then having a second musical phrase that repeats twice, thus making like a larger sort of song form. So that's fine and dandy. And then we resumed by saying, well, music isn't just that, it's a sequence of these sort of forms. And as you see, it says nested sequence, because that's
Can you zoom on that? It's so cool. Can you zoom on those?
Yeah, I'm not seeing the stream, so you'd have to let me know.
Oh, yeah.
So this is another...
Zoom even more.
Yeah,
if you can.
I can do this.
Perfect.
So so we understood that we want to be able to create anything from the single note being drawn on a piano roll here to the sort of larger scale form to the sequence, which is a sort of a three pattern form, and then wrap that inside of a larger structure that's able to contain many different parts. This doesn't really show the product. It more kind of shows the way we were thinking that day. So you'd have two nested sequences that differ in the form structure, BAA and then ABA. And then you'd have a simple object, like sort of a piano roll that just plays a single phrase. And then you'd have something with like a randomized element. It's sort of a surprise me moment. That could be anything from a drum fill to sort of a piano phrase that brings you to the next thing. And then the C part would be a combination of several objects in whatever way, shape, or form you conceptualize music. And if you think about it, this, like when we talk about what we should play on our instruments, many times we'd say, well, these two bass lines make up the verse, and these two bass lines make up the chorus. So you play one verse and one chorus. So just in saying that, I sort of packaged the information in a very similar way. So this was like a very strong realization we had, that we can say something like play the verse, then play a fill, then play the chorus. So the fill is just a few notes, but I mentioned it in the same way I mentioned a verse or a chorus. And that's a very interesting approach, because usually in DAWs, we're used to seeing information in a certain resolution, which is an audio clip or a MIDI clip. And we usually kind of keep it at that. You know, some DAWs you may operate with more larger scale forms, but usually that's what people deal with. So anyway, moving forward, usually after we do something very basic, I go ahead and make something that actually looks like a sort of some interface. This is this is not product design. This is to get our imagination and our creative juices flowing. And this is something that I've been doing for years in any product that I developed, is just putting something that makes you want to aspire to develop the product and you know, get curious about what you're doing. So the working title for it that we quite like is Thema, I guess, or Thema, depending on how you want to say it. And you see it as also a logo concept. This is also something we do very early. That's the branding of the product. So this is like a single thing that kind of evolves, and this sort of explains the concept. And what we see in this area is the result box, which is super important part. It's like we constantly remind ourselves that at the end of the day, people already have a visual language that's very common for understanding what music is being played. So we kind of adhere to that in this area. We have a lick bank, which could be like a cool factory library of things that we gave you, and also you'd have an opportunity to sort of develop ideas, bring them back into the lick bank, and then rework them. And then there's some sort of process here that I won't go into detail. I guess Eyal and I would explain explain it better later, because in this part it's just exemplified the idea of having some phrase and working through a series of icons that each one of them is a process that you apply on the phrase, and then it becomes from funky fill, it becomes a funk hook or something, and then step 4, profit. So yeah, I hope this has been kind of coherent. And Eyal, please stop me if it's not, and we can go through other things. These are all.
This is awesome, because this is actually the first time that I'm hearing this said in a coherent way. Because usually when we're talking about this, it's like it's fragmented because we're still coming up with this. But now that you've said it, I've actually learned a lot about what it is that we're doing, because now you've shown this as a complete process, right? And because compared to how we usually talk about it, which is talk about this button or this.
That's so true.
This
you get
label
lost in
or
the
something.
detail.
Yeah.
You get lost in the detail. Yeah, because you develop things and you work through every line of code and every color of a button, and then you're like, wait, what we're actually doing is facilitating this huge process. Blah blah blah. Here is the last thing that maybe I want to go through is this is like such a crucial part that we understood about the language. So this says if chord equals C minor, add ninth. Like this is like a phrase you would say to your friend when you were playing, like, if the chord is, every time the C minor comes around, just play this note, right? So this would create some sort of rule that you would apply in a broad way and not worry about it, as opposed to going into every piano roll, looking for every time that chord appears and then adding that note. So this is why I want to kind of pause on this, because it's one point that I felt like we had an aha moment, that we realized the like potential power, or maybe I realized that Eyal had these sort of forms better cemented in his head before I did. We understood like the power of creating a sort of very easy, visual, friendly way to create these sort of phrases, and to break away from, again, opening 1,000 MIDI clips and editing them and manually positioning notes and stuff like that.
Awesome. So maybe we should dive in and talk about what we were just discussing right before, like a couple of hours ago.
Right. So fast forward a couple
Fast
of
forward
weeks.
a few weeks of doing this, just because I'm guessing we're going to do a lot more runs like this, where we're going to go through the history of why and how, just because of the nature of the stream.
Mm-hmm.
But I thought it might be cool to discuss on this interesting place where we are now. Can I do this? Oh, good. Okay, because I want to see if I can see your screen in a more good. Okay, so where we are now is that what we're looking at is this is a concept that Or just made a few hours ago, right?
Right, earlier today.
And this is a development, I'm assuming, of things that we talked about, over the last couple of days, because we there's a lot of building blocks here that we're trying to define. You can see every square here has all kinds of like interaction points, and we were just trying to think of before Or made this. We were talking about ways to define what does it mean to connect one thing to another. You can see these little like colored inputs on top of the square, right? This is like an early thing that we defined earlier, just a couple of days ago, and one of the things we understood, and we just talked about this before the stream started, is we started to talk about ways to symbolize the connections between things.
Mm-hmm.
Right? Do you have the last thing we did during our chat, like
yeah,
right
of course.
below this?
I have everything. You're talking about these ones?
No, the thing we did was that like 2 hours ago? When was that? Right below that.
Oh yeah, there you go.
Yeah. Here we go. Yeah, this was like some conversation we had about this, right?
Mm-hmm.
So here's what I'm just gonna take this as if we never stopped talking about this.
Mm-hmm.
So what I was the part I was trying to kind of suggest in the just when we were working on this. So the thing we started to, one thing we noticed was you notice here is that there's the colors, which is the types for the connections, and they have also names, right? These are two concepts that we started to talk, because we said that if a box is I call it's almost like a function call in a language,
right?
And the color is the return value of the function, like it's a type. So
Mm-hmm.
a purple thing, let's say the purple is like a musical sequence, like a piano roll. It can only connect to an input that's purple.
Right.
But there could be multiple things that you could connect. Like here, there's a generator A, B, and C, like three things that generate different types of music, and each of them can connect to any of the purple little inputs on the octave.
Right, and one thing that's important to note is that you can think about it like each one of these processes or functions sort of shows what it requests up top. So it needs you to insert here. You can see it better. It needs you to insert like two numbers basically. So it needs to know if it's an octave. We can see it here. It needs to know what octave it's in, and let's say a velocity value, because that's just like a random thing that I decided that it needs. None of this is cemented. And then it needs music to apply on. So this is where we're at. We kind of had a breakthrough today that we understood that the function flags its inputs like in this visual way, and allows you to assign without using any like wires or sort of very complex, ugly visual way. So it just says that generator A is the music input for octave 1, And this would mean that if generator A is making a note, octave 1 would make another note that's 2 octaves above it in a certain velocity value. So this is like a very basic building block of perhaps a much more complex music making machine. We call them devices. I guess that's a big part of the way we're thinking about this process is that we're going to make all these sort of devices, that's the way we call them, that take a note input from a generator or a piano roll or a sequence and then apply all sorts of interesting functions on it. So so that's the main thing, the fact that we understood the visual language that sort of explains what we want. We want things like octave 1 to have. We want it to have a way to show its values and then show what kind of music is being driven into it.
Yeah. So there was one thing that I was just I wanted to suggest we experiment with before we. So I wanted to see if we can have kind of try to have a layout where basically everything is laid out vertically. Like imagine generator A, B, C. Imagine that you lay them out in order in a vertical way. And then I thought that, that if you do something horizontally, it's only if you put a block like around this, like let's call it, parallel block or something. So there's going to be like special things where that would mean to do things horizontally, but there'll be like some layout. The reason why I suggested a layout, it's not carved in stone or anything. It's just like something that I was thinking of. The reason why I suggested this layout is because I thought it would be cool as a way to explain what can go into something else as well. Like, for example, if you say, I have generators A, B, and C, and then later I have the octave, it would kind of be obvious that an octave can only connect to something that's above it. And you cannot connect to something below it or to the right or left of it. Like it kind of... and it will also mean that if you would put the octave above the generators, it's not like it's going to disconnect it, right? It's not going to work because it would kind of explain what depends on what.
All right, it will bring certain other challenges, but let's go through that example thoroughly and see.
Yeah, and it's possible that would mean that the inputs need to go on the left side, right? Because we could also make the box, kind of grow according to the number of inputs. So let's say the number of I'm just suggesting, by the way. I'm not saying it's going to look good. I'm just throwing some random hypothesis.
Can you just go through the exact layout so I can kind of put it in front of us?
Yeah. And again, I don't know if it's going to look good. It might be look horrible. I'm just throwing some thought. Yeah. So the idea. So what I suggest, maybe if we do it like this, then we can maybe move the inputs to the left side and do the inputs vertically. But the block would grow depends on how many inputs it has, so it will look good.
Yeah, so the one with 4 blocks would look like this.
Yeah, because nothing stops us from dynamically setting out the height of the block, just like you do in something like a modular synthesizer, like a synth edit, where the module could be super tall if it needs something.
Right. Well,
the reason why I thought about it this way is that
here is just the amount of basically these you can pile up in a single screen without scrolling. That's the trade-off, basically.
That's true. So,
but sorry to just because for the sake of the discussion, and this is something I would say if we weren't streaming even. If I'm going to do this, why not like just show the input? I have enough space to just show everything. I don't need the flags. The flags are nice, but I can just do this.
Oh yeah, so what I thought was, well, you need to know what the name of the generator is.
No, I know, right? But it would just say it instead of just, well, this is economy of space, but here it's very wasteful because it just takes up the name here. This is a lot of empty space here just to have these 4.
Right, but I'm just saying, yes, and you're right. But what I thought is this would actually allow for things like hovering over the inputs and seeing the full detail or something, right? Like this, it would kind of, one of the problems I saw with when the inputs were on top was that if you expanded them, text
like
is, yeah, exactly. So text is left to right, right? So this is basically what I'm suggesting in a detail view, right? To look or something like that.
Gotcha.
Because if you have because we can't really with the inputs on top, we don't really have anywhere to stretch them to. We can only just place them somewhere else to show like a
this
longer
would
text.
be note. So I'm gonna just a lot of these. This is for the audience wherever they are. A lot of times, just to get going, I would invent something on the spot. So a generator has a value of a note, and it has a value of subdivision and velocity or whatever. But the main thing is to sort of demonstrate, to have a clear way to demonstrate what we're talking about. So the note, this would generate the note C3. And like what happened is I hovered above one of these green rectangles. Eyal, correct me if I'm wrong. And when I hovered above the first one, I saw the first one is the input is note. So it has a sort of note input from somewhere, and it's C3. So this generator would do something with this note or whatever. So I want to do the same thing for the octave here because it has multiple types of inputs and kind of seems interesting to me. Let me see. 235, that's 133. So let's make this the same size. So yeah, this little module is called octave, and as we said, it needs music, and I invented that. It needs an octave and velocity. Again, this is not an actual thing. This is an idea. So this moves to the side. Guys, if you have any questions, it'd be cool also for us to sort of go on tangents and answer them, or maybe it will spark something new for us. So feel free to jump in and do things other than ask for free plugins, which is also cool. But, you can do so much of that. So this is maybe also a cool example where you see like a preview of the, you see a preview of the input, and then when it expands, when it expands, you'll get like the full thing generator.
Exactly. And it's interesting. That's actually, we talked about the language before. That's actually something that some IDEs will do, is that they'll give you like some hints when you go to edit something. They'll give you the hints on what this is, but if you don't if you're not actually editing this one box, then you will only see like the value that you put in there, like a.
So what I would think, if going with this approach, just to make it, just to point out advantages, because I pointed out the disadvantage, but to make an advantage out of it, it does give us a lot of room to add more functionality to the slot. So that means stuff like quickly deleting, duplicating.
Exactly.
All that sort of stuff can be visual buttons. If I want to duplicate, I can just draw a little duplicate icon here. And then, that would sort of be, instead of a drop-down menu or a pop-up or a right-click menu, something like that.
Exactly. And the reason why I thought about this, again, this top-down thing, is first of all, it would make it very easy to do things like reordering, which would make sense a lot, I think, in some situations.
How do you mean it would make it easy for reordering? Sorry.
Like if you think of the list itself as something like what would be a good example? Something like a Google Calendar, right? Where everything, like you see the date, specific dates, and you can kind of drag up and down things. Take this thing up.
So you're talking about the list of these. So
yeah, because the reason why I like this is that would allow to do a bunch of vertical things packed together. Like it's let's say we keep these. Let's say that there is some list, that the list of devices in your device, because we're in some device right now when we're editing this, supposedly, right? Like you're writing a harmonizer, you're writing a generator, you're writing something. So the context is, let's say you have you're in the blank page, right? And let's say you do something like the idea is that there's something when you think about, like, let's say you drag things from the bottom, from the top toolbar, from the side toolbar into this, right? You brought the thing in, right?
Mm-hmm.
And this is going to stick to there's going to be a slot there, like an empty slot of sorts. When you hover over it, it's going to kind of highlight or something.
Mm-hmm.
It could actually have some cool animation, because it would be like, for example, let's say there was already something between them. Like, let's say there were already two devices, and you try to drag it in between them. It would kind of do a little animation of them.
Yeah, it will shove them aside.
Shove them inside or something like that. There's going to be something very clicky, like very precise about touching them. And I also thought that it would be cool, because then if we add a special block that would do a left to right thing, it would be like it would have like a special mechanism to it, and it would be interact, and the left to right block would interact really well with the things above and below. Like, it wouldn't be so chaotic. Because one of the things I'm always trying to avoid with these things, we talked about this a little bit, is the feeling you get from stuff like Max, synth edits, blueprints in Unreal, where you have like this graph that can do everything, but I feel like it's very chaotic, because you have two modules connected, and one can be on the left but also on the right. It can be on top, but also, like, you can drag them, you can kind of reorder them anywhere.
Right.
And it's kind of up to the user to have a patch that makes sense. And I think we can.
That doesn't happen.
Exactly. It usually doesn't happen. And also, usually maybe you start with something that makes sense, but then you're like, oh, what if I patch this into this? And then you realize that everything is a big pile of big plotted.
Right. So
wire.
what you're saying basically is, let's try and recreate the same device we had before, but in this sort of methodology, visually.
There's an interesting thing that was put in the comment. We should look at the Bitwig's grid from MIDI. Let's see what specifically are we talking about.
Oh, sorry again for the infinity thing.
Oh yes, I think I know what you're talking about. You're talking about the node grid or whatever it's called, right?
Mm-hmm.
Let's see if we can bring it up.
Yeah, I'm showing it on screen right now. This is actually sort of you can call it like an underlying thing that we're doing as well, because it's also like a modular system with individual blocks, and each block has a sort of function. But there are several substantial differences in the use cases and our approach to it. This is actually what Eyal said he'd rather avoid, in a sense. Yeah.
So exactly. So this is exactly the thing. So there are. So I really want to explain this, because this is actually something very important. There are. I love that you brought it up, by the way, Olaf. Thank you so much for bringing it up. So Olaf said that we should look at this feature from Bitwig, the thing that's Or is just looking on his screen. And what Bitwig has, which is great, but they have a modular synthesizer, and it has MIDI features, right? Just like Synth Edit and Max, they all have MIDI features if you do MIDI routings in them, and that's cool. Like, it's very interesting. But Or and I have quite a lot of experience doing products in modular synthesizers. Previous companies we've worked for use those extensively. So we've had like a lot of hands-on experience doing complicated MIDI routings and audio routings and stuff like that in those modulars. And what we're doing is actually not a modular synthesizer. And to make it interesting, it doesn't process MIDI, even though it does create MIDI. So what we're doing is something that's not operating on a note, or on a note on, or a MIDI CC or something like that. It operates on a sequence. It operates offline. It could operate in real time, but it operates on a sequence of things, on a list of things. So if you, it's quite a different concept from doing a modular. In a modular, you kind of patch, the output, and then you can do some calculation. Like there's, they have stuff like adding in between. They have stuff like adding more notes, like adding a note stack. So take one note and put out three. But those really are just basic MIDI effects. They take note inputs and they put note outputs, or they put an arpeggiator in there or something. But what we're doing is actually something that's that lets you evolve music from, let's say in our system, you could do stuff like put one note in and get a full composition out. Like that would be the kind of things.
Maybe we can actually just go through that exact example,
Yeah.
and just to explain, we can imagine that riff A is the best riff ever written, which is just a single note, which is the first, like the open E of a guitar, and then if we'd want to make that something more interesting, we'd probably want to do things like change the subdivision, generate more notes, change the octaves, maybe transpose. We want to apply certain elements and actions to the single notes. So that's I guess the basis of the system, is like, what can I do to this note that will output something that is interesting music and usable in a wider context.
There's amazing comments here. There's amazing comments here that I want to read. Olaf is saying, is this like an instrument that you can play in the end? Do you imagine this as a live played instrument? I always love to press fill buttons on drum machines. Yes. So this is going to be something that would allow you to, you can, it's going to be a combination tool. You can have an offline control on this and use this for composition, but you mentioned exactly like a use case. Like you could also have this connected to a MIDI controller or some button and have it generate crazy fills. And it's going to actually allow for pretty complex things. We didn't show a lot of demos yet, and we will be showing quite cool demos as we develop this, because we have some prototype version of the code doing interesting things. And but yes, so you could have it generate drum fills. And that would be actually a really cool use case that we have to talk about.
You could even randomize the selections, so a certain area would always play a drum fill with your own selections, but it would never play the same fill twice, which is also an interesting thing that we think will differentiate it from working within a DAW. So it would be sort of like telling a drummer, hey, when this part comes along, just go crazy or play this fill, as opposed to just manually changing the fill every time it appears. So
yes.
Yeah, this would allow, basically, if you have, we want to be able, I think we said something really that captures the essence of this, I think yesterday or whatever, last week. We want to be able to make a device, we call it, like what you're seeing right now, make a device for any musical sentence you're able to say. So if you want to say, every time the A part comes along, I need there to be an increase in dynamics, but less of this and that. So if you can just compose a phrase that says it, we want you to be able to have a device that operates in that sense. And then we don't want you to be forced to manually apply any of these devices like to each area. You could, but we mainly want you to sort of have a style guide at a certain point where these musical phrases up top are yours and these devices are yours, like your customized approach to making music, basically.
Yeah, and one of the cool things that it does, and you can see a little bit of that in Or's design. We're actually working a lot on that part. Is you can see that on top there's all these like phrases, right? They're kind of on top. You can actually make devices that would work with your phrases, right? Let's say you write a few phrases and you want to create like almost an infinite amount of manipulations on these phrases. Like, hey, let's hear this phrase with more notes, with less notes. Maybe I want to hear this thing. So there's quite a lot that you'll be able to do with this on a composition scheme with your own phrases.
Just to answer the question, we do want it to be able to process live MIDI as well, but it's too early in the process to sort of lean on that and say for sure that this is the main thing it would be. We're mainly like dealing with use cases that are offline composition. But there's no reason that it wouldn't be able to work well with live MIDI. It's just that at this point, saying anything for certain, is kind of difficult. Um, I'm honestly saying, like, is witchcraft a software or is that a joke? Like, making witchcraft. I'm like, why is there like a DAW that looks like this that's called witchcraft that I don't know about or something?
Yeah. So So Olaf says that the grid is not live. Our instrument will be live, but it will be live. But it is important to note that first of all, it doesn't do what the grid does. The grid has an actual synthesizer in it, like it's a modular synth that does patches. I didn't go to see exactly what do they let you play live or not live, but the grid is. But the idea is that they have a signal routing scheme. That's basically the idea of the grid. So what we will do is that we have a composition scheme, but you can connect anything in this composition scheme to be live. So just to give you an idea, there's or if you can zoom in on your screen a little bit.
I'm just preparing things for
oh, okay,
future.
okay. Oh yeah, so I can. I'll let you. I'll zoom. But let's say in theory that you have one of these devices, and there's a number input there. You can say, well, that number is going to be connected to a MIDI CC, right? And a number could be something pretty crazy, like the number of the probability of this lick playing in a sequence. That's the number. And if so let's say the sequence is playing and you just move your MIDI controller, that phrase is going to come more often because you brought up the MIDI CC. And if you bring it down, it's going to be less often. So you can control something like this, but you can also control something like something even wilder, like something duplicates time. Like how long does this thing duplicate? Is this going to make it half time, quarter time, eighth time, or double time, right? So you can control the timing of this. You could control quite a lot of this with just by connecting one of these ports, one of these like little inputs into a live MIDI, into something that you do live. So yeah, it will be able to do this live, and you can. So it's a very, very unique way to think about these pattern sequencing. And you mentioned stuff like drum fills. That's a very, very good reference. See. So Olaf says, I systems. It creates fractal trees and shapes with a simple language. That sounds awesome. I got to try this.
Olaf, are you looking for a job? Pro audio. You seem to bring up really good points.
Let's see. I have my screen here. So it's iSystems. Is that it? Automatic trading systems? Choose your broker. Is that it?
Are you trying to get us into a pyramid scheme? Is this what this is about? Did you learn about Pro Audio just to get some money off us?
I don't know. What am I looking at? iSystems. I see a lot of stuff about finance.
Maybe iSystems Audio or iSystems MIDI. It probably is like a very generic name. So.
Yeah. What am I looking at?
It creates fractal trees. Fractal trees would be a good prog name band. Like a prog band name. Sorry.
Oh, it's L system. It's like a. Okay.
Yeah.
Okay. In the L systems article, let L system grammar-based system for simulating biological growth. Oh, that's interesting.
Okay.
Realistic trade introduces a new featured many plant. This is awesome. Wait. I gotta do this. So we'll start by creating a binary tree. It isn't a very realistic tree, but introduces a new feature that many plant-like structures possess: branching. The technique used to create this tree will be used later to create a realistic fern. That's so interesting. Rules for the tree. The tree has an alphabet of 6 symbols: F, G, plus, minus, and. This is, you know what? Surprisingly, this actually is very, very close to things that inspired our concept. Even though this is awesome.
Yeah,
wait.
Really
this
great.
is awesome. This is really awesome. The sequence is the same as the sequence described above. That's so interesting.
We're making an upside down version of this.
Pretty much.
Yeah.
Okay, so the way I understand, I need to read more into this. This is so cool. So my understanding is that this actually is also inspired by what we're inspired by, which is functional computer languages. And that's different from stuff like object-oriented computer languages or blanking on the word, or linear procedural style programming or something like that. The idea is that you kind of chain these expressions basically to create one bigger expression. Yes, here we go. So the string will be replaced with. Okay, so this is exactly it. This is like what's called currying in functional programming, where you create these like chain of functions that will expand to much larger functions. So yes, so this is very much in the scope, I think, of what we're doing.
The plugin SynPlant. Beat Juggernaut is saying.
Plugin SynPlant makes so much
rings a bell.
SynPlant. Let's see. SynPlant. Yeah.
Can you show the screen?
Yeah. Let me do that. This is so interesting. I love it. By the way, thank you so much for these comments. I need to.
Yeah, this is super cool. You guys are. Oh yeah. It's the AI one that makes a synth out of any sample, right? I think Mike in one of our streams took like a rubber chicken and made a synth from it. It's pretty cool.
Yes, pretty cool. It is pretty awesome. Yeah. So and just to give you an idea, the idea of these evolving trees and stuff, it's not like something new. It existed in many different domains, and I'm sure it exists also in audio processing. In a way, like I definitely have seen lectures about doing signal processing like this. I've been in places where in lectures, I've been in lectures where some people, for example, in ADC, that's a convention that happens in London, and I've been in one awesome lecture about somebody tries to write a full, like a modular synthesizer like this, described as the tree with kind of straight up functional nodes. It's very very interesting. I think it's a very interesting model, because one of the interesting models about these graphs of processing is that they allow for a very unique feature, which is pure functions. It allows to say that if you put in an expression, like in our case, you put something like a music generator of sorts, or a music changer of sorts, then we're saying that this thing will sound the exact same way if you pass the same music into it, and that's something that you don't get in a traditional modular synthesizer, because in a traditional modular synthesizer, let's say that you chain in something into a filter, right? A filter has states, like it keeps memory of what's before it, and it doesn't sound the same, in the next things you put into it. So it's basically a stateful machine, right? It keeps being modified, and it has things in it, or a reverb, right? Another example, right? The reverb keeps, like, it has memory of the last few things it put before, and it's not like you can identically kind of start a reverb from the middle, right? If you want to hear the sound, you got to start the sound from the beginning, play the entire sound, because you want the reverb of the previous times as well. Right, there's something about signal processing that holds memory, and these, like we've seen now with these L systems. Ooh, I got an ad. That's fun. With these, trees, is that those trees and those like mathematical. I don't know if you can see this. It has those mathematical expressions, like these kind of stuff. These expressions are usually mathematically pure, so that it will always be the same result every time you put in the same inputs. I haven't tested to see their exact semantics, but that's how these are usually treated, and it's a very interesting way to observe a process. It's different from how most general purpose programming languages work. But we're trying to get into that space, but maybe a bit less abstract, maybe a bit more musically focused.
Right. Circling back to what we showed before in Figma.
Yeah, we're gonna stop that screen sharing.
Just with the exact same conversation. So again, infinity screen, and there we go. So basically, even though the underlying engine would be a sort of, you could break it down as a code, as like the L systems thing. We always like to give, to present a very nice and friendly interface to people at the level they're prepared to face the software. So right now we're showing a sort of a considerably deep level of the actual product that we'd like to make. We'd like a product that doesn't deal with individual notes all the time. It should deal with this area, and once you create something you're happy with, you should be able to go into a place where you make an entire composition work using the same tools. Like, let's say you took this list of devices, as we call them, that duplicates octaves and transposes and sort of takes a single note and makes a beautiful chord out of it, or a chord sequence. You want to zoom out and say, well, when does this happen? Under what conditions does this happen? And you want to see it like in a broader scope. So that's one thing. The other thing is taking this very kind of abstract code language and giving it a sort of user-facing visual interface, which is basically what we're seeing right now. So Eyal, at a certain point, to try and explain to me, because I had I don't have as much coding experience as Eyal does. I guess not a lot of people do. Just to explain it to me, I do have some. I have enough knowledge that something like this made perfect sense to me. That he described sort of processes in these sort of code container kind of way, where flow music, aka riff A, has these actions in it with these inputs, etc., etc. So what we're seeing here, all the way down here, is basically that, but presented in a way where you see like the musical material you're working with and the processes that it will go through in order to create a new piece of music. So right now, just to keep going on the same track, I did like a recap for anybody that's just joined us. This is also good. It helps kind of cement these ideas, and we start believing them ourselves. This is a sort of new approach we started exploring that takes these objects and kind of stretches them out and puts the inputs on the left side. So here you would see the kind of music that goes into octave 1, which should be, let's say that it's riff A. And then octave 1 would have, two numbers, that one of them would be the octave, the other one would be velocity. And then we would have transpose, and if I'm not mistaken, the input for transpose would be octave 1, right? Because it doesn't take the music from riff A. If it's linear, it would take the music from here.
Exactly. And if you remember, one of the things we talked about was this idea of kind of assuming that by doing something like an arrow.
Right. I forgot.
Right, and then you can that would even help. But this is exact. But even if you don't have the arrow, this is correct. Right?
Yeah. I meant to do this. Sorry.
Yeah, but you're totally right. This is, but I think this is exactly is the, I guess the. I think this looks great. By the way, I think this is, and I know we're you can see we're just prototyping boxes and stuff. But surprisingly, I love this because I feel like, if we can look at these diagrams and we can understand them, that first of all, that really helps me write the code because I'm implementing. Olaf said something very interesting. I would love an operator where I could put numbers in a row like 1 and 2 and would alternate between 1, 2, 3, 4, 3 and turn random, and it would output random 3 and 4, but two things as many be 3. Yeah, all of you, you're hitting exactly, like we probably have prototypes that do exactly what you're suggesting. Yes, this is a very, very big use case on this thing. Like one big use case we're always talking about is just different ways to mess with structure, right?
Yeah, like the ABA thing I showed before. So I can show it again. One of the things we started from is sort of sequencing song forms or phrase forms, and then what you're suggesting would be to sort of have a connection into that, or something that you can apply on something like this that would alternate between song forms. So one of them would be BAA, then ABA, and then the third one AAB, and you can sort of have this really cool way to have a sense of organized randomness, you would say, because the repetition would be of a certain piece of music, possibly, but then the form would keep shifting. So yeah, I have a feeling Olaf would really enjoy this product.
Yes, exactly. You're gonna like. There's something really interesting that that you can do once you think about music as not just as like sequence of MIDI notes, but you're saying, well, there is something about the bigger blocks of music or lists of musics or stuff like that. There's a lot of cool operations you can do, including anything to do with random, right? Anything to do with the because a random, for example, a random transpose is actually very easy. Like you can write it in any MIDI effect or something. But a random song form is much more difficult because it's so stateful. So it's very hard to do a random song form in an effect, in a MIDI effect. Like you need So it does. There's quite a lot of interesting things here about the model, and probably over the next few days or something, we're gonna be able to go over a little bit about the implementation of how this works, and I can show. I have some. I don't have this. I don't have an implementation of what Or is designing just yet, but I have implementations of like some internal workings of that because we work on the engine and on the kind of prototype design on the same thing.
I'm just organizing some things.
Yeah. So this is very interesting. So there's a great question here that I want to answer. Bit Juggernauts asks, will it be microtonal? And
you guys are knocking it out of the park.
Yeah. So the answer is yes, and I'm not sure exactly how it will express microtonal, like in terms of UI. But yes, so first of all, one thing that we did, by the way, in all of our products, even like our people don't know that because we didn't like expose a lot of features that are related to this. But first of all, I don't know if people know that, but I worked on a microtonal related product called Fluid Pitch, and another product called Fluid Chords, which have like these microtonal features, like you can kind of tune the keyboard into microtonal
and they're
ways.
Also like massive hits, these products.
Massive hits. And the way we did all of our products, and by the way, that includes even Beatscaler, Eon ARP, like all of our other products, even Mindset Drums, all of them are kind of initially written with the idea of doing, let's call it MPE, like this polyphonic expression with different tunings and all that. And this thing, like we will probably, yes, so it's very likely we would find a good way to express that in the UI, because there's a few different ways of expressing microtonal. One way is that you want to just have a global tuning system. That's how a lot of synths do that. Like they give you like a global tuner, and then you say, well, if I have a C major, maybe the B is slightly sharper, or maybe this note is slightly flatter, and you kind of have all these like tunings. So that's one way to do microtonal. Another way that people sometimes like is that they like to have independent pitch control, right, over certain things. And that's probably something that we will add. The tuning thing will probably add very early on. But some of those stuff, by the way, can be added on the synth level and not on the composition level. Like you can actually, you can load a Scala file, like a tuning file, into synth, and this would work with this. But the more interesting way, I think, is how you can
We could also
how you
have a
can
block like this. Sorry, that's
Yeah.
called tuner, and we could offer
Tuner.
like an octave of keys with microtonal tuning that you could
Exactly.
do for like you'd have a device. Like this would be. I'm not saying this would definitely happen. But I'm just saying our approach with this product. It's not out of character that we would have a device called microtonal tuner that would allow you
Exactly.
to customize. Just for a single device, it will allow you to customize that, and you can apply it anywhere.
Exactly. So there's a few ways to treat this. Like you want to tune in the level of the whole song. Like you wrote a song and let's get like you can, and a tuner can be something that tunes like your keyboard. Like, hey, every C is sharper, every C sharp is flatter, or something. Or you can do specific operations over specific notes. Like, hey, only in this section, I want the notes to be in this Arabic key or something.
Mm-hmm.
Yeah.
So, meanwhile, we were taking questions. I kept on drawing nice.
Oh, perfect.
little
Yeah.
boxes,
Let's go on with that.
I was just for the sake of the argument to we're basically let's put these one in front of the other. Okay, so the approach we came in with is having the inputs on top and then having the object itself. So the function itself is a generator or an octaver or harmonizer, whatever it is that the sort of nested process is. And then Eyal came up and said that maybe we should have the inputs on the left side and just have larger boxes so they appear like this, and we have sort of enough real estate to, when you hover on top of them, you'll see what kind of music this affects or what kind of values.
Exactly.
And the trade-off.
And by the way, just to give you something else, one thing that's missing. What would, if we do it this way, and the way we talk about both these octave 1 transpose repeat, they would also get variable names like B, C, D, whatever.
Right. So octave 1 could be my octaver, and transpose could be 4 semitone up. Like you could actually like give them specified names. That's what we're saying right now. What I did here is just like a.
But I'm just saying there's going to be like, let's say you create one, like let's say you drag one into the project, because you could create two of the same one, right? Two of the same type. So let's say you have an octave, then you drag in another octave, right? So immediately when you put this octave, it's going to get assigned a variable name, like B.
Yeah.
Like, right, because
like riff A, what appears here? Yeah, it should be like this. Sorry.
Yeah, and B is just a short identifier that's going to help you when you reconnect the thing into something else, right? Because you might connect, because you can connect with the arrow into the next one, but if you don't, you want to connect this to the something more down the block, then you use the name.
Right. So the arrow is just a sort of shortcut, and that's why what I also drew here. So instead of having the specific identifier, it just says, like the input here just says arrow. So it says whatever this is sending, I'm getting it. And maybe when you hover on top of that, you see the specific name of this. But I just thought it was like a cool way to kind of show it. So the trade-off I'm also showing here is that, this is like, I would say, at least like 60% of the screen, maybe even more, is dedicated to this list. But it comfortably, it will allow for 3 or 4 of these on top of the other before you go into scrolling and stuff like that. And then most of the space is wasted. So it's currently wasted. So unless you would have forms with a lot of parallels, this approach, even though it will have pop-up windows probably and stuff like that, it would be more inviting to do long, like more complex structures. Because of the economy in room.
Yeah, but wait. The idea is the reason why I thought about this top-down thing. First of all, we are probably going to have other complicated blocks that will expand sideways, like a parallel block or something. But I think the idea is you have multiple devices on screen. Like was what I was thinking. Like let's say you have this one screen that you're working on, and then you have very quickly you get into opening another device, or so you have 3 or 4 devices, and this is where the sideways
Right.
presentation.
It makes a lot of sense if you
Yeah.
have multiple devices.
Yes.
For a single device, which is the use case we've gone with so far. Um, well, even now, you have to consider that viewing multiple devices. Well, there's like I can find disadvantages in any approach. That's a big part of what I do is find disadvantages in things. But yeah, let's say I have this, and it's called device one. Um, Maybe if this is the area where you construct devices, it does make sense that it would maybe be like this, and then you'd have another one, and then possibly a part of a third one, or maybe you would have just a block that says, I always like doing this in any prototype, is leaving room for potential.
Yeah,
This
and
would be a plus
exactly.
device.
And the thought process I've had is you might have, for example, let's say that like you would usually do it if you have something connected to, like, let's say device one has something, from device two that it talks to, like device one actually calls device two. So it's very likely that
Right.
you're actually
So
like you're working on them at the same time. Like you're like, oh, you can connect something in device one immediately. You can modify like you don't need to do like page swapping when working on something like this.
right. So you would have device one as a possible generator or as a possible music input for device two. You would have it set up already, and because it's a device, yeah, it would appear like this. So you could have device one, and now the process here is repeated, but with the input from the first device.
Exactly. And I think then the idea is that your creativity a lot of the times would be about chaining devices. Like for example, let's say you have device one, device two, and then device three is using device one and two as generators or something, right? Like device one and two
Yeah,
are
device
interesting
three could
generators,
just
and device
be.
three is like a sequencer.
Yeah, that's what I was just about to do. I was just about to go
Yeah,
like this.
and I think that and I think having it like this would help you kind of get a good overview of what is you're doing without, because if you have just one window on screen, your I guess your natural action would be to do everything inline. Like you're like, oh, why would I put something in another device if I have to keep switching pages? Let me do everything in the one device.
So this brings up
Yeah.
an interesting topic of conversation, actually,
Yeah.
that deals with in UX and user experience. You have to consider what it is you're recommending, like the user to do, but by just not in a very explicit way. So you have like a visual way to recommend doing something. So when your laptop lid is closed, it has like a very small slit, an opening in the middle. So it kind of says, hey, if you put your finger here and push up, the lid will open. So this is a sort of very simple way to describe what I'm saying. The reason I'm explaining this concept is that if we're at a point where we can decide if what we want to recommend is an all-powerful single device that does many things, or the existence of several devices side by side that feed into each other to create this sort of horizontal mega device together, but then there can also be apart. So there's like we could also like have both approaches at the same time and have a single device be on the entire screen, allowing you to do several things, but also have like a button that says duplicate or add device, and that will imply that you can add something next to it and it will kind of shrink down. And it would require scrolling maybe inside the device, because maybe I have another process here in parallel that I'll need, in order to see it, I'll need to either zoom in or whatever to view it. So this approach would definitely tell people, don't make complex devices, just make several of them. So it would mean that people are more drawn to sort of say, well, this one does these three actions. I can open another one here, but let's just, it's much easier to see this information just on screen without scrolling or zooming and stuff like that. So that's where my head is at. I actually don't hate it. I think it's cool to sort of recommend a way to use the product, and also it's cool to like have compartments, to not say, well, this is a device that's supposed to solve every one of your problem in just a single huge list of things, right? This is sort of the approach we're trying to avoid. We're trying to steer more towards think about what happens to this note, and when shouldn't be something too complex. You need to comprehend what happens to this note by the end of the process, and then okay, once you understand that, what happens next? Are we taking this idea and developing it further? Are we sending this idea back to the music bank here to be used elsewhere? So there's something to this that if I switch over to this screen, this is like a more relaxed visually, like a more relaxed version visually. What I'm seeing here, the blocks are bigger. There's more like compartments, more areas of operation, but this one is sort of a mad scientist approach of I want to see everything spread out, and I don't mind pop-ups, and this is a more well-organized approach. So I'm trying to explain to myself what I want out of this thing.
Yeah, and there's still like a lot of things in the micro that could be improved with this, but I wanted to have the idea where like I definitely like the idea that that's against one of these things that when we talked about all these like visual languages like Blockly, and some of them I think because they kind of evolve both to the right and top to bottom, like the area where you work on can be very clustered once you do something complex. And first of all, one of the reasons why I liked about this is that I like the idea that you kind of hint about the top to bottom development or open a new device, right? Like you kind of like this. These are like let's call it first class citizens, and I mean, first of all, you can find ways to, I guess, to minimize some of the information on screen so it's more concise. Like first, I mean, if we do it like this, we can also decide that that blocks, maybe the inputs would show up on the right side as well. And like I told you, we can also use meta blocks that will expand left to right, but they'll always happen within specific blocks. Like for example, let's say we're saying let's have a special block that does an if statement, right? That's something we talked about, like do an if statement. So an if statement will push other blocks to the right, but only by a little bit, and you're still, you're not going to expand forever on the right. Something like that.
So, just wanted to put a comment on screen, and I'll address what you said. I think this is a very good point you're making, because we sometimes tend to try and solve a problem that we haven't reached yet. So that's a good point. Just saying, hey, let's focus on getting the system right, and then if we have to minimize stuff or make the UI more efficient, we'll figure it out. Usually we're able to do that, but we're also working under a sort of condition that this system in general is not like it should have a sort of technical aspect to it. So it's okay to see a pop-up menu, and it's okay to learn something new here and there. It's not like the in Beat Scholar, like the single pizza where we want to just click it and it's on, click it and it's off, and split it, and that be happy with that. Here we are willing to have a sort of learning curve, and that's also, hey Mike, how you doing, man? Relates to what Beat Juggernauts asked. Or said that we should release the manual 30 days ahead. I want to address that because I have zero intention, and I bet Eyal feels the same. I have zero intention to release a product that is very difficult to use. Even though don't forget, you're watching a stream about us developing a very intellectually intense and complex product, but the success measurement of this product would be that you would need 0 time to use it. And for me, that's like, if you learn something about using this product, it should be additive, but it should be usable from the moment you open it, and it should play music as soon as you encounter it. So don't worry about us making something that's a big code-like sketch, even if it's a part of the UI where people would, some people, maybe like Olaf, would say, oh my God, I'm so happy these guys actually pulled it off and made something so modular. I'm also this kind of user. Basically, I always, I joke about, my strength in being a product manager for plugins is that I don't like plugins. And it's not that I don't like them, it's that I like ones that sort of facilitate making music, because you're like a drug addict looking for a fix when you want to make music, and you don't want to open a cumbersome interface that asks you a ton of questions just to get something done. And this is what we feel DAWs are most times. So you can imagine that when we're looking into solving a problem like getting inspired and composing music, we don't, like, our initial response isn't, great, let's make a language that requires you to learn code. That's not where our headspace is at, but you are watching the process that gives birth to this, like, very simplistic, possibly wonderful product that will help you make awesome music. Again, you have to keep in mind, I don't know if you were here at first when I showed our earlier sessions. We came from a position of saying, like, we just want you to be able to easily create song forms within seconds. So now we're zooming into the point where you're making, like, complex decisions about a single note, but the broader context here is basically getting to this point where you're describing how your song behaves, and you're making decisions on larger forms, and you're having fun just imagining what your song can sound like without going into each and every single note and changing it. So just imagine talking to your computer and saying, man, I wish this part would, sometimes appear during the song here and there, and I wish this fill wouldn't play the same every time it arrives. It plays slightly different. And just imagine talking and describing what you want out of your song and then having it happen in front of you. And that's the sort of ease of use we'd aspire to. We'd aspire to either offer that visually or maybe even by text at a certain point. Sorry for going on about this. This kind of hit a soft spot for me as the guy in charge of user experience and that sort of aspect. Yeah. Yeah, I wanted to put your mind at ease. I mean, Eyal is the same way. Eyal is a brilliant programmer, and is very much into modular synths and music tech. But if you ask him when he sits down at a piano and if you ask him when he wants to make music, he sits down at a piano, which is I guess one of the simplest interfaces possible for music, if you think about it. He doesn't open 16 plugins and 12 piano rolls. And that's, for me, the same with the bass guitar. And this is where we're coming from. And we're willing to go through every complexity imaginable in order to get back to this position of sort of immediate creativity you're getting from instruments. At least that's what we're trying to do,
Yes.
So inspirational.
Yeah. There's always the saying about people like Rick Rubin, who the saying that they sit next to you in the session and they don't do anything, but then they say yeah when it's like the good idea. And so this is my.
No, I love it. It's the opposite. Like, I love it. That sometimes you just need everybody. You know what? Keeping on with philosophy, everybody needs to feel approved. So I appreciate you yaying me. Going back to this, I'm actually enjoying. My eyes feel all right looking at this.
And I know there's micro stuff. I know that to handle for this to kind of work.
Oh yeah, there's a bunch of things here.
Yeah, and by the way, like you're seeing, a lot of these blocks can definitely be more compact in size. Like there's no need for all this size if there's not all these inputs.
Yeah, of course.
So
I gave it like a default size. Sorry for making excuses, but yeah, it's just easier for me to do it like this than give it a specific size to each one.
Yeah. And then like the cool idea is that you always want to be able to have operations like insert something in between, whatever. And the reason, so that's something that I actually think about often, right? Because when you think about these devices, a lot of these devices are devices that are created by the user. Like, for example, device 2 or 1 in your example. And so they're user devices, and they could have inputs as well, right?
Mm-hmm.
Like you can say, well, device 1 has an input for like a music input for something, and then if your device 3 is using device 1, whatever, let's give them some better names than 1, 2, and 3, then those inputs would show exactly the same way in device 3, and you can patch device 1 into 3 or 2 into 3 or something.
So let's say that this device starting to get fried here. This device is turning the riff into, you know what? Make it interesting. I had this up top, and then device 2 make it more interesting.
Yes.
This is basically it, right? Because you take a note, you make it interesting, and then this device takes and runs the previous device again. It makes it more intense. So maybe this one is an arpeggiator, and this one arpeggiates whatever the arpeggiator is doing and creates sort of a second line. And device 3 sort of
form,
organize or form.
Or something, right?
So this one creates a form. That's why I brought these things. That should be make it 1, then make it 2, and then make it 1 again. So this is just to give sort of visual cue as to what the sequencer is doing in our head.
Yeah, and by the way, a cool thing, by the way, about the sequencer, we can do a concept that's done usually in modular synthesizers, that sequencer could have a variable input, and then you have like a plus. Like
right.
it says input, like when you first load it just says plus. Then you're like, okay, plus, or maybe it has the first one by default, and then you add, and then you have the first one, the second one is a plus. You click plus, a second one is added, the third one is, kind of put to the bottom, stuff like that.
Right. So something like this. If I were to describe the inputs, I do want the inputs for the sequencer to have sort of a unique feeling to them. I mean, not the inputs here, but it should be like a detail that shows you the relationship between, like there's what goes into it, and then there's the order that it sequences in. Now we can do it like explicitly, where this order reflects the sequencing order, where you can go like, well, device, come on. I flattened the text because I'm dumb. There we go. So the first one is device 2, and oh man. So we can also do something like this: device 2, 1, and then 2 again. Maybe we'll try this on for size. And if the list is longer, then we have to think about if we want to do this, and have the sequencer block be huge. But basically, this is maybe a good point to explain that a sequencer in this context just means these things happen one after the other, as opposed to what we called mix, if you remember in our previous conversation. We also discussed, because these are sort of processes that happened usually at the end of what you're doing. So you want to organize the information. Once you created it, you want it to appear in a certain way. So the difference between between a sequencer and mix would be just that. Mix would play device would play this one and this one simultaneously, basically, as opposed to one after the other. So if this creates a chord and this creates another chord, you could decide either they played simultaneously or one, then the other, then the first one again, then the second one again.
Mm-hmm.
It's a very common thing in music that things either happen at the same time or one after the other. It's actually also happens in reality in general.
And you know, I think I actually like this use case. We can actually start to think of this use case of, let's say you want to generate chords programmatically, just like you mentioned, right? So we were saying, you know, one way is this, major chord. We're like, okay, play a major chord, but it's also so what is it? What is it? So you know, there's things like that, like a MIDI harmonizer, right? Those things exist.
Yeah.
There's stuff like in Pro Tools, it's called Note Stack. But what we do is we're going to generate something that has a timing to it as well, right? There's a length that it does. It's like a quarter note, something, right? You say, so that's also an input that the generator does, right? The generator could take a root note, right? In the future it could say take something like an inversion, but let's ignore inversions for the sake of the example, right? And we're like, okay, it takes a duration, or it doesn't, or it has a fixed duration, like quarter note chord, right? That's something else. But let's say it's a quarter note, and you give it the root, and it builds some chord on top, right? Maybe the chord is what it does, right? The chord is, let's just for the sake of simplicity imagine that it's always a major chord or something, right? And let's do another one that's a minor chord, and we'll talk about later how you can build one in terms of the other. It's can also be fun. Like you can make a chord, a generic chord generator, but then have one for major and one for minor, right? Like as presets, as prefabs, basically.
Sorry, 1 second. Got a technical difficulty here. Sorry. There we go. This is the first one, and you said to make a minor one. I should really start making these smaller. So this would be green inputs in our sort of visual language, these two. The root note and the type of chord. And then it should have like only green ones, the way I understand it. Meanwhile, Beat Juggernauts is saying, will there be templates, and or will we be able to make templates for device fractal trees that we like? Definitely, yeah. The entire purpose is for you to be able to customize and invent ways to make music with this. So if there's a certain device that makes a sound that you like, you can customize it and make it your own, and possibly even share it with others. And imagine that you can give knowledge away about making your music. So you can give a way to arpeggiate a chord that only you know how to program into this. And this is something we're excited about because we feel like, this is one of our favorite things to imagine when we're making products, is like how people will communicate with each other using the product. So yeah, templates are definitely it. And also, like, for us to be able to explain the product, we should have presets that kick ass, that sort of deliver the message.
Yeah. So this. Yeah, exactly. So this. Let's say this thing takes, just for simplicity, I'm gonna simplify this. Yeah. So let's say it takes a root. Let's say for simplicity, it takes a root and duration, right?
Duration.
Because when you think about how this is going to be used, like let's say you want to
no chord, it would take duration.
Yeah, let's imagine this particular block is always major, just for simplicity. I'm just not going to.
I will specify it though, so it's apparent on the.
Oh yeah. So that's the name. That's the name of the entire device. Is my what it was.
I thought the name of it would be generator, and then it would be a generator that can generate a chord or a note. So it's like a matter of how we package it. So a generator can do just C2, and the chord can be empty, and it would just say C2. And then if you make a chord out of it, you make a chord out of it. Or is that not the intention?
Well, I guess that would be a more generic.
That's what I'm
yeah,
thinking.
yeah.
You're thinking about a specific input.
Specific. Yeah.
Oh, so it's not okay. So it's more like
it's more like a harmonizer, but it's
but it's we could have a block that just that's called a major chord, and then you just select the root note.
Yeah, exactly.
Or even a piano roll that
yeah,
has
but also with duration, which is interesting because you want to do
root
you
note
think
and
about
duration. That's a great
duration.
device to offer.
Exactly, because when you like what I'm thinking musically, I'm just going to play something on my keyboard for a second. Like let's see if my piano can work. Okay, so what I thought, like musically, let's imagine that you want something that like just uses, for example, right? Just these these blocks, but you can make them shorter and longer. So, for example, you can make them. Let's say you make a piece of music with this motive, right? So you might do this, or you do. Right, so you will be kind of have all these variations on how these chords are connected, and some maybe you'll do a short, long, short, like a right. That will be like these like phrases that you want to be messing with, like so I'm only taking a C major. I'm just taking C major, D major, and E major over just a steady bass line of C. And there's actually a lot of music that's written like this with a pedal point. Mm-hmm. And then the idea is that you will be able to once you're always generating these major chords, which is not the most interesting thing to do generationally, but it will be interesting once you create another generator that creates a phrase on top of that major, right? Okay. Because you can do because you can do something like, okay, here's a phrase generator that uses the major chord, and that thing will do, C, D, E, quarter note, quarter note, quarter note, and then C, D, E with quarter note 16th notes quarter note or something, right? You can like you will just do variations of phrases with that duration and root.
So you would do something like input here randomized value into the duration or something, and then you would sequence several of these.
Yes.
So you'd have something like let's build this device real quick.
Yeah, like the other generator, like the next generator in line would use this major chord generator and would just be just sequencing variations of this. Yeah, like the idea is that you'd have a generator that would have it would just have a bunch of major chords one after the other. Mm-hmm. Just whatever. Let's say let's give you an example. This would be 3 major chords one after the other in a device, right?
Yeah, but what makes them one after the other in our language would be a sequencer.
Yes, they'll all be connected. Exactly, they'll all be connected to a sequencer. But the idea is that you can create a chain of those, and then you can pass a variable into how long is each one, and create a sequence of phrases. So the first 3 can be we can start with a fixed number like 1 quarter note, but then you can pass a random you can make a third device that just does phrases one after another with a randomization on the durations. So it's always the same order, right? It's always 1, 2, 3, but it could be, and it could be, and it could be,
Yeah, I understand.
and you have all of them one after the other. So here's what the music would eventually sound like with some randomization. It would be something like or something, right?
Yeah, I understand completely the music part of it. I just don't understand um, how to compose it in our sort
Oh,
of
okay, okay. So let me
visual
explain this.
language.
So let me explain. Can you?
Because the randomize is basically a sort of block in itself that you should be able to connect, or it should take in inputs from let's say here it would be the duration. So the generators need to sort of interact with the randomized block for it to affect the duration. So
Okay, okay. So I'll explain. So here's how I would structure what I just said.
something
First of
like
all, I would
this.
I would actually make a device, with a big device, where the user would do the chord, right?
Right.
Oh, you already have it, right? Can I see it? Can you zoom a bit more on it? Yeah, can you zoom a bit more on that?
One
Maybe it's
second.
hard for you because
I'm
you need
doing
the.
like six things at the same time. So
Oh yeah, look, because
bear
I just
with me.
realized that you actually need to also take stuff from the right side of the Figma window.
Yeah.
So you needed like way more broader
I
view
keep
than
like
I do.
bringing the interface up and down so I can zoom in. Yeah, so I would have one generator that's this thing, right? Let's put them side by side. So it's 3 generators, A, B, and C. Whoop. Correct so far?
Well,
Or is it just one that I randomize a value of just one of them?
yeah, I think you just need one device. Like you would actually have a device called major chord, right? Let's say that's unless we provide that device in the library. But let's say let's say the device is built. Let's say the device exists. You don't need you don't need to
It would
see.
make sense to not construct a major chord as a device, for me at least. It would make sense that this is a prefab thing that
Prefab.
we just, yeah. That's like
Yeah.
giving people a one note. You just here's a note, play with it.
Okay, so let's imagine this thing exists, right? Let's
Mhm.
say the user already
Or,
built the
or we
prefab.
already built it.
Yeah, and now you're saying now what you want to do is you want to create a device that's a sequencer, right? And that thing, yeah, I mean, and this whole device would create, for example, let's say just create 3 major chords, one after the other.
See, when you're saying it would create 3 major chords,
Yeah, you place
that,
you place these three major chord calls, 3 major chord use of devices.
so
One,
so
two, three.
it would have A, B, and C. So 3
Yeah,
variations.
yeah, but inside of the device, exactly. Yeah.
Yeah.
Yes, exactly. And then yeah, we have A, B, and C, and each of those will here you would type in like another note, like another.
Hold on, let me. So this would be my bank of used music, and then the first device would be a sequencer, right? The first, I don't know. We should definitely find a different name for a thing here than this entire thing, but let's
Yeah.
do that later. So a sequencer would take major chord A, B, and C and sequence them, right? So
Yeah.
it would be major A.
Yeah, we could just say A, B, C, right? Because these would just be like, especially if it's auto-generated name, it would probably go along these like a naming scheme.
Mm-hmm.
A, B, C. But a sequencer, and maybe this is a sequencer maybe the module is not like a regular sequencer. It's a sequencer that also takes an order as the
input. Okay, cool.
as the input, right?
Good night, Olaf. I feel like we at least owe him that. Yeah, so it would have an input that says order. Why does it stretch the word That's so bizarre. Um, so I'll just type everything out thoroughly so it's clear to me. So this would be it. Right. So the order input is what we'd want to randomize, basically.
Exactly.
So that now there's the question: if I have a block that says randomize, there's the question of what kind of interaction happens in order for it to be randomized.
Yeah. So random. We need to talk more about how does random works. But I think. Hold on. Oh, I forgot something else. The other thing that should be here is that the duration is. Let's think about this. Let me think. How would this work? Because I would want something like. I don't think how to do this, but we want something like a different duration on each one.
So I would try and, even not as a sort of solution, but just as a thought experiment, try and think about randomize in the same sort of way we think about the sequencers. So a sequencer goes through and, checks what it can sequence or has inputs that you can decide. So I would say randomize locally says, well, what do you want me to randomize? And then you could say randomize, like, it should have sort of a sequencer order, sequencer like this.
No, well, what with this? 'Cause there's some more complication to this. So first of all, I would like to. I don't like the idea of that there's, because that adds some the idea of a special function that can modify something instead of having an output. So we probably need a randomizer connected to this, but wait, I don't want to put the randomizer in there. I want to do something else. I'll show you exactly what. Let's start with. Let's keep it like this for now, just because I don't want to do the duration part yet.
Mm-hmm.
Let's open another device. Before that, you need to add an input to this device, right? You want to have an input for this device, which is just a number. It's the order. You will need some way to connect like the order all the way to the input. Like you can kind of click it and say device input, and that would kind of open a green box on top of the device itself. Yeah, exactly. Order. Perfect. Yeah.
So this would mean that when major variations is applied in this broader sense, it would require an input, but it would also require music.
No, this is the music now is generated. It's done by chords.
Self-contained. Okay.
Self-contained, yeah. So cool. this one is fixed, and then we have another similar graph like that. By the way, I like the idea that the graphs are the graphs themselves are kind of floating in space. That's kind of cool. We'll have to think about that a little bit. There's something fun about it.
Okay.
Just like there are in Figma, there's something fun about like kind of browsing a world of organized graphs.
All right.
Versus a world of like random objects. Anyway, it's just.
So the next device would probably hold this one first, right? The major variations device, and this would be the randomized chord sequence, I guess. And I don't know what it wants.
Yeah, we can even start by not wanting anything. But what it can do, let's forget about even the randomize for a second. Let's just do it without randomization, just for the experiment, and then we can add that. So let's say you just want to create a special order about these, right? So you can say, so when you think of what the order does, like let's say an order could just mean that the first one is ABC, the second one is BAC, CBA, whatever, right? So musically, what it means is that let's say like order 1 would be or something, right?
Mm-hmm.
And let's say order 2 is right. So
Right.
you could have 1, 2, right? So or you can have right 1 1 2, or you can have right some order of these.
Mm-hmm.
And the idea is that you should be able to do you should be able to either, like, first operation would be to do it manually. Hey, sequence with order 1, sequence with order 2, sequence with order 5, right? Just run them, and all of those you can connect to a sequencer as well to have some. So you have to have like some long form music.
Yeah. So the order would be just something like even 1 2 3 or ABC
Mm-hmm.
or Jackson 5
Jackson 5.
or ABA.
Mm-hmm.
Right? So that would be the input for major variations, which is the device we kind of made before.
Mm-hmm.
So how do we get from that to the point where I have several of them lined up? So maybe
Yes.
I can create several major variations and then sequence those in a way. But
No, so the first thing to do, I'm gonna start with the simple one. The simple one would be, what was the name of our previous device? Major variations. Good. So you just put them you put a major variation, and the input of this is order is a number in this case. So the order is 1.
okay.
It's just randomized, right? And order is 1. For the next one, the order is 2. Order is 3.
So wait. So we are missing significant interfaces to get to this point. So first of all,
Like how do you say what's 1 and what's 2?
yeah, you need to be able to assign. There's even a deeper question. So
Mm-hmm.
you need to be able to not only assign a certain order, but assign several sets of orders and have that be wrapped in sort of its own container, which is the number of that order that calls the form. So
Yes.
it would mean that
But
this
I'm
input
intentionally,
is-
yeah, but I'm intentionally ignoring that, and I'm doing something way more primitive. But you're right. That would be an even next step. But I'm actually ignoring that step just for the simplicity of the operation. What I'm assuming for this purpose
okay.
is that sequencer or the sequencer object already knows how to take all the different options of a sequence and put them one after the other.
Okay, and
Let-
we're also assuming that you have some sort of way to see what they are before you select them or something. So we are
yeah,
saying,
yeah.
we are
I
saying
mean,
that basically a sequencer already banks the option, the possible combinations. So we're saying like the sequencer already says you can do A, B, C, whatever, all these
Yes.
options, and then
Yes.
it says, and then it says like whatever order 1,
exactly.
order 2, order 3.
Exactly, and
Cool.
we'll talk soon about how this can extrapolate, because we can actually do stuff when you talk about devices that are pretty much meant for random generation. We can also do stuff that kind of they take a list of things and they create all the options. Like it's almost like shuffling a deck of cards or something, right? You're like, okay, give me all the possible shuffles or something, or
Yeah. So you would have three of those major variations with different orders, and then how do we get, like the question was, how do we get to the point where they are randomized? Like I know I can
Okay.
I know I can resequence them,
okay.
so I can
So-
even create a larger sequence, but
So random is a great question, by the way, in general, in things like that. And there's a few ways to express it. I need to think more about how to do this. But what
yeah,
I'm thinking
we
we'll do.
it now.
Yeah, but just as a first thought, what I thought we could do. First of all, the thing that you'd want to do is probably something like we need a meta block. We talked about this. It's kind of like a for loop. Like do this 3 times, do this 5 times, or something.
Mm-hmm.
So the for loop would just mean something like that. So, but it's run x times. That's basically what it means, because we wanna kind of extrapolate this to many. All right, or n times is usually what people use, run n times. That's something nice. And there's some so when you make a meta block like this, and then you put just one operation in this, which is major variations, right? It basically this thing lets you kind of chain another block, maybe under it or something, right? Change another thing. So first of all, you can start by just doing it on the bottom. And when you do like let's say you put this in, and below that you put in major variations, like it's above major variations, which is kind of important. Yeah. Exactly. Now here's the fun thing in a for loop. If you do a for loop, there's another secret variable that gets passed in, which is what number of repetition you're in. And you will have that if you're connected under the run n times block, then one of the options to connect to order is going to be a loop number or something, or which repeat am I on.
So that would be an input for the run n times block.
For the major variations block. So instead of connecting to order 1, order 2, order 3, the number there, it's like, because you could type in the number, right? There's going to be a number there that you can type. Instead of typing it, you connect it to the count. And then you just have, by the way, 1 major variations, not 3.
So this would change what major variation is, basically, because of this meta block.
Yes, it will connect differently in each of, let's say run n times would have 3 times, like you actually type the number.
This would be run n times.
No.
Or
the run n times is like a device. It's like a special device, and by the way, n is like an input to it, right? It looks like all other blocks that we have.
Yeah. I'm saving time.
Yeah. And the number is just how many times to do it. How many loops do we want?
So 4.
4, right? And so the first thing to do would be in major variations, we can connect something like which run are we on, right? That would be a start.
Which one of what?
Not one of what. Which run? Like, for example, we can say that the first run is going to be order 1. Second time it runs, it's order 2. Like, just by order. That's the simplest way to look at this.
I'm stumped. Where does this happen? Does this happen here in where it says order 1?
Yeah. Instead of writing order 1, write down something like it's going to be something like the loop index. I don't know how to call this. There's some number that's repetition. Which repetition are we on? I don't know what to call this. I need to find a good name for this. Like, it's the.
So it says repetition 1.
No, it says repetition. I know
Okay.
this, and what this is, this means that you're going to run this 4 times, and every time it's going to have the actual number of the repetition be set the order directly. So first time you run it, it's going to be the first order. Second time, second order. Third time, third, right? So this is a way to create something that gives you 4 loops of 4 different orders, right? So each loop has 3 chords, and this would multiply this by 4 and reorganize these 4 loops into 4 different things.
Again, we are assuming a lot here.
Why? What are we assuming?
Because if you'd ask me what am I looking at, I'd have no idea.
Sure. I'm talking about blocks that we haven't defined so well yet. I know, but this is the idea. Like, this is how you do something like a for loop. You do it once, and then you say every time do this. Now, let's say you want to add randomization into this, right?
Yeah, That was our original goal
Yeah.
in doing this.
Right. So what I want is to run 4 times, and each one do a different each one do a different one. Right? Don't do 1, 2, 3, 4. Do other numbers. I don't know, 5,
Right.
3, 2, 1. Right.
Yeah.
So what you do is, you need to do add a random block right before that. Oh, I see the question here is from Fabrizio. Sorry, I was very late. Will this just produce MIDI messages, or you want it to be a host? I think a MIDI generator would be more useful than another host. Just makes sense. Yeah.
Don't worry,
so
it's not a host.
it might be a host, but it will definitely be a MIDI generator. Even though it's it will be a MIDI generator. It would work as probably as a plugin as well.
Yeah, but meaning it's not like we're not making a DAW. We're more focused around solving, not even solving, but reinventing how you compose music and interact with MIDI.
Yeah. So let's say you do something like this, and then you say repetition. Let's see, repetition. Yeah, exactly. So repetition is a really bad name, by the way. I know I need to be more clear in my thought to have a good name. Yeah, cycle, or I don't know, which repeat.
It just means out of the possible major variations that we specified here, out of the possible orders, which one are we on?
Not out of the possible orders. This is one of which runs are we in of the loop, because the loop runs 4 times. We said run n times. It's like a loop. So out of each one, we want a different result, right? We want a different order. So we're saying. Yeah, right. So musically, what's going to happen is first loop is going to be, whatever, and then second loop is going to be, or something. Third loop might be, right, or whatever, and anything so that's how you would mess with variations on music. That's, by the way, the real goal I'm thinking about is that you could kind of instruct it, and now randomize. Random. Let's call this thing random. It's a randomize that's green, right? It's a green device because it puts out a number. It's not a music randomizer. It's a number randomizer. And the randomizer takes as an input something called a seed. We'll talk about what a seed is later. But that's to create. Some sort of a predictability in the random. Like, for example, if you want to use so it's almost like a pseudo random. It's not because a seed will let you, if you want, it will let you repeat the same result whenever you run the device.
Right.
You can still have, for example, like we're going to do. We're going to use a different device per loop, a different result per loop, but it's going to be predictable in the sense that you can actually reason about that, or you can create a random seed. That's another option. Then it's never predictable. Yeah. But it takes a seed, and the seed is going to be connected to the cycle, and randomize is going to have an arrow connected to the major variations.
What do you mean the seed is connected to the cycle? The cycle itself is the input for major variations. So is this like a case where the seed is over here? Or is this a case where the seed is over here?
No, the seed, it's exactly where you wrote it. I'm just changing the connectivity I'm patching it differently. I'm saying that seed is patched to the block before it. But basically, we probably can do this with an arrow, by the way, if we have a green arrow. So we can actually put an arrow from run n times into randomize, and then an arrow from because in this case. Yeah, but it would be a green arrow because it's a number arrow, right? That would be the only difference. But basically, runtimes gives you which cycle are we on. That's what this function does. It gives you every run which number we're on, and the arrow below that is going to tell you will bring the result of the randomization into major variations, right? It's going to be patched with this arrow.
Yeah, so it would. It would present a different number here every time. So, but this would mean it would be easiest to think about this as random cycle or something, or even random number.
Yeah,
So
exactly.
instead of the input being a specific order, like order 2,
Hmm.
it would always be changing because it's right now connected to the randomize.
Yes, and the thing is, the interesting thing about the seed thing that I've done is that this actually means that this would produce like even though it would sound random, this would actually produce the same result on every playback, but it would be this like it would be different from the first time, the second time, the third time. Like every time the loop would run, it would be different music, but the music would be but the entire sequence is actually going to be the same.
Yeah. So
And
it's consistency on a larger scale, but on the local scale, it's
yes,
randomized.
and if you want to have real randomization where it runs this, what people usually do is that they run like you can pass in a real random seed, right? Instead of this n seed, you can for example you can say that this seed is let's say a multiply of some random seed and the count or something. Like you can do a bunch of different like inputs to because you want to make sure that random in your program is controlled
Mm-hmm.
in a composition program, because you want to be able to replicate, I think, the parts that you liked. Or you want to experiment with different random seeds. Like you might want to pass in a seed of 50. That's a literal seed. And then you say, oh, I don't like 50. Let's hear the result with 49. Let's hear the result with 30 or something.
Right. This does feel like an area we need to sort of
Yeah.
bring to this level, because I think that in the area of like linear processing, let's call it, in our software, we are reaching a point where we can look at this and say, well, I understand what's going on. But if you think about the very basic function of what you're trying to do, you're basically trying to do something that we want people to do all the time, which would be to randomize a sequence. There should be a sort of wrapped version of this, let's call it, that allows you to kind of access these sort of actions in a very agile way, right? Because
Yes.
this would seem like a device that I would pull many times and then use it more like this, right? So
Yes.
it would be basically you could see the 4n times blah blah blah, and then
Mhm.
it could be like seeded randomizer or something.
Exactly. Like, but by the way, this is really the power of this, right? The power of all these blocks and functions is that you create things that have names and operations. Like, and by the way, and a device can also run other devices. So you can say, for example, something like a device could be called run n times and then pass the count into a device. Here's a device, right?
Right.
And then the device will do the loop for you, right? That's
Yeah.
the device would do like file, and the device might do even randomization for you. We'll talk about how this could work. Yeah. So, and by the way, these are things that I think are super interesting in terms of code concepts, because those things happen in programming all the time. Like, how do you express a higher level function by using a lower level function and still hold an element of flexibility, right? Like so the user can say, I don't want to keep defining loops and random seeds and blah blah blah, but I just want to pass in my device in here. I wrote my own arpeggiator. I want to connect it to this looper, right? A random looper, let's call it. This high level device, right? And I think this is actually something that we can support. And all you need to do by supporting it is by I want to show you something cool. I want to switch to code land for a second, just because I want to show you how this pattern works and how cool it is.
Cool, but then we'd have to wrap it up.
Yeah. It's going to be the last thing that I'm going to show. I'll just show it like very briefly.
I stopped sharing right now.
Okay. So
I'm just doing some tidying up in what we did.
Yeah, so I'm gonna write. I know I don't want to go too deep into code in this stream, but I will just show it a very cool thing that functional languages generally can do. And in this case, let me change the, how can I change? Oh, this. Here we go. Okay. So I'm just going to open like a C++. I'm going to write this in C++, but it's really just going to be a very boring, like fundamental concept in the language. So one cool thing that C++ does is that it allows you to pass a type as like an input to a function. So you can write like, let's say a regular function like the one we had now. Like we had a function called let's do a function for now called print, right? That would be the function. And usually you need to give that function something. Like you say, this function, let's see, zoom in here a little bit. Can you see the text on the screen?
Yeah, right? Looks good.
Okay. Yeah. So I can say something like, int number, right? And that would be a very straight up function. And then this function would just print in student cout number, right? This, and then when I call this function, I say print 5, right? That's really how a lot of our functions look like, right? It's like you pass something into the function, you pass the 5, right? That would be our input, and it does something then with the number. And that's super easy. But now it gets interesting when you say, well, I want a function like, instead of print, I want a function that will do something and the user will tell it to print. Right? And so it's kind of weird. So it's almost like you want a way to do something like, instead of passing just the number, you want to pass the what. Right? You want to pass the what. It's super weird concept. So how do you do that? How do you pass the what? So in C++, there's a few ways where you can do that. One way is that you can do something like template type name func or something. I'm going to call it do something. This is going to look weird, what I'm doing, but it's going to be cool. So what I'm doing is, what it's going to do is it's going to do something like a func do something with the number. Now and this looks weird. Like, why would you do that? Why would you do something like this, right? You're asking yourself a very interesting question, right? Like, what's the use case of this, right? Why would you write something in such a weird way? Well, let me show you. That means that I can create multiple higher level types that act on this do something. So I could create one type called a struct. Struct is the name of a type in C++. And I could do something like a struct. Let's start with the struct printer. That's going to be easy. And the printer just needs a function that says do something int number. And the printer is just going to do the same thing as before. It's going to print it. Student cout number. Right? That's going to be like the dumb version of this. And then when I call this, right, I can do something like do something, or let's say I had a number, int 7, and then do something, printer, int 7. I'm too tired. Int x equals 7, and then I don't even need the x. That's just a printer with the 7. Here we go. This is my entire program. What did I do? Oh, sorry. This should be static. Static void. Okay, here you go. That worked. And that prints the 7. Awesome. And now you're saying, why would you do this just to print a 7? Well, now let's say we have something that's called a multi-printer that instead of doing the same thing like printing, right, this is going to do a for loop int I equals 0, I lower than 20 plus I, and it's going to do the print in, but it's going to do it 50 times or 20 times, right? So now when I pass a multi-printer, you see I have a bunch of printing happening, right?
So many sevens.
So many 7s, right? And now let's add, we can add a randomizer. We can just say, don't print this. Print the random, or print this number times I, right? So this is a crazier version of the multi-printer, right? Here's a bunch like this could be like a crazy randomizer almost, right? It creates a sequence out of my number.
Yeah.
And so it's just a concept of instead of putting here, instead of doing this here, like just typing the function explicitly, I'm going to create it with the option to pass a different device. So I can write a printer, a multi-printer, a random printer, whatever. And here, I could just pass it in when I call the function. I don't need to teach that function specifically what I want to do.
That's actually a beautiful example. That's not even, I wouldn't say it's more complex, at least to me. It's not even more complex than what we showed in the UI graphics, because it does contain the sort of building up of elements in order to create a larger context, and then changing things within the larger context while maintaining the structure. So that means that once you go into the individual blocks that we showed, that for n times do this and that, seed randomizer, even when you're out of this context, when you finish with the micro detail, it becomes more clear the higher up you go. So the more uses you find for it, the better you understand it, and the more you tweak what you're getting from it, the more you understand what it does and how to use it better. So that's a very cool way. Like the very last thing you did with like randomizing the order of the numbers, it's a very eye-opening moment for me, because it's a time where I realized, wait, I know how to depict in the UI what you just did, basically.
Yeah.
Which is, it's awesome. You haven't done this exact demonstration for me yet. So this is a sort of live moment that this happens occasionally, or almost every time we talk. That Eyal shows me something that makes me go, oh, now I understand many things that I didn't before. So this is another one of those moments where I just now realized, wait, I actually, in the language that we just showed for the past 2 hours, we can perfectly exemplify what you just showed.
Exactly. It's such an interesting concept when you think of, like, okay, I'm not just passing numbers here, I'm passing a how to do something. Like I'm passing and that really helps when you think of what devices we're going to offer also in the library.
Right.
A lot of devices should be stuff like like we said, do this thing and randomize. And then what they take from the user is not a number or music. It's like it's a what. Give me a device to do this.
Yeah.
With. Give me some
what
object.
I need in order to work is a randomizer. So
exactly.
If there's a device called randomized note sequence, it needs to know what kind of randomization you want.
Yes.
So it doesn't like it could have music embedded into it, and that's a very interesting concept. That sometimes what the music is, but you just want to be moved by a certain variation. Sometimes you know what the variation is, but you don't know what the music is. So that's it kind of reminds me of Eyal Or taking like the idea of a note contour, so the shape of a melody dictating the movement of the music, and then the input can be anything, like a single note or a chord or whatever. So this kind of allows us to flip this on its head and say, well, maybe you know the kind of feeling you want out of the music in every possible way except the music, and maybe you know the music exactly, but you just want to apply different processes to it, and different types of randomization, different types of sequencing. And I guess that's the strength, because when people compose, sometimes you have a fragment of a melody, sometimes you only have a beat, sometimes like you come up with sort of a different thing every time, or maybe you have a certain approach where you always come up with the chords first, but you just need help to put them in a certain order, or put them in a certain form. And I guess like that's what we're trying to do here. We're trying to if no matter what kind of producer or music maker you are, we want you to have like these sort of aids to get yourself going as quickly as possible. And that's a very difficult job because of the sheer amount of variation between people's work methods, and also it should be a sort of fun road and a surprising road where the feedback you're getting makes you want to further explore what you're able to do with this. So yeah,
Yeah,
it's
exactly.
pretty cool.
Yeah, and,
Pretty
and,
cool
and,
stuff.
and by the way, this is also why I was trying to go for like a very uniform way in the connectors, right? Because then
Right.
when you create things that are not so traditional, they're like crazy connectors, they're like meta connectors, right? Do this 3 times and randomize, and then right. But instead of doing this as like a chain of things, which is like more procedural program, like a for loop, and then if this, and then like writing this like sequentially, you have these meta objects, and you just put
Yeah.
them in order, and they kind of make everything tie together nicely.
Yeah, and also that's sort of we set a goal for ourselves when making this language that everything, like if you know how to operate the most basic thing, you know how to operate the most advanced.
Exactly.
So it's the same. Eyal gave this really amazing comparison to the game Portal, which is a game we both really love. And the mechanism of opening one portal and then placing the exit point at a certain area. Like as soon as you encounter that, you're like, well, okay, I can step in here and go through there. What can you do with it? And then they come up with these ingenious ways to sort of create puzzles with it and add elements. And that's sort of the UX lesson we take from that, is what is the most basic main interaction that if you master that, you can master all the levels of the thing, so of the software. So this, our moment here is like doing the construction of a device and connecting the inputs should result basically in you making 5 minutes of amazing music from 4 notes that you started off with. And this, understanding that will take you all the way across. And hopefully, once it would be fun if we actually keep with these streams and we'd have like a documented road to whatever this turns out to be. I just, it would be really, really cool when I think about it to look back at this stream like a year from now or something.
Yes.
So
Anyway, this was an awesome session, but I think it it might be time for a break.
Yeah, I have like an hour to sleep, so I'll do that. But yeah, I guess we'll definitely do it again, and we actually made progress that I'm not to sound like pessimistic, but I didn't think we'd actually make this much progress in this session, considering the stream and the questions and all that. But I really feel like it was productive and pretty cool, and people really vibed with it, and understood what we're doing. So that's also. I don't know why I'm surprised. We have pretty intelligent and beautiful users.
Absolutely. Yeah. So it's
right.
thank you everyone for watching, and
thank you, Fabrizio. Hopefully you can catch up. This was very long, but we actually kept going back to what the stream started, like to what we're doing. Sorry, this is getting late over here. So if you rewatch it, we're basically coming up with our own sort of language to compose music, and it's a very taxing and interesting and intellectual process. And yeah, I guess it's very much meant for people like you that look into sort of a deeper approach to composition, but it would also result in like a piece of software that would just help you make cool music in a simple way. So yeah, join us for next time. I guess we'll try to do this more frequently. Eyal will do coding streams, I guess, almost every day. And I'll jump in once we have, I guess, enough content to sort of keep doing these sessions and make progress. Cool.
all right.
Bye, Eyal.
Good night, everyone.